Hello, we're going to do number 11 from your problem set for section 1.2. This actually ends up being a very tricky problem. It doesn't seem like it at first, but you'll see how it goes. So suppose that on a calm day an airplane flies from city A to city B at a constant rate of 150 miles an hour. And on the return trip, the same airplane flies at a constant rate of 128 miles per hour. So first question, what is the average of the rates the plane flies? So what part A is just asking is what's the average between 150 and 128? And you just divide by 2. So here you're going to get 278 divided by 2, and that gets us 139 miles per hour. So that's the answer to A. Again, it's the average of the rates. So when you have an average of two numbers, it's just add the numbers and divide by the total. Now B is where it actually gets tricky. Now we have two ways of doing this. Let me show you the way you probably did it, where we have a plane and it's starting here and it's going, this is A, and it's going all the way out to B. And then it turns around, so let's actually put arrows here. And then it turns around and it will fly back to A. Now on the way there, it's flying at 150 miles per hour. And on the way back, it's flying at 128 miles per hour. Now the reason we can't just add these together is that each one is a different time, so it takes a lot. It's a lot less time to get from A to B than it does to get from B to C. If you're familiar with frequency distributions, which I'm going to do this using a frequency distribution in a second. Now you can't just add the two together because they take different amount of time. Though they go the same distance, it's going to take them a different amount of time, so we can't just add them together. So what we're going to do is we're going to label the speed. All right, we'll call it S. And I'm going to call this S total. Okay, think of it as the overall total speed of this plane from start all the way back to the finish. Now, the speed is going to be the distance, which I'll write D total. So it's the total distance over the total time. Okay, so we need distance and we need the time. Okay, so let's come down here. Alright, so the distance total. Now, I actually don't know how far it's traveling because it doesn't give me a time. You know, how long are we traveling? Like, for example, if we were traveling for 1 hour, this would be 150 miles. So we don't know that. So how are we going to figure out the distance? Well, what we're going to do is we're just going to call this right here from A to B some distance D. And then the distance back to A also has to be D, right? Because the distance there and the distance back have to be the same. So the distance total is actually D. Okay, that's the distance from A to B. And then D again, the distance from B to A. And that gives me 2D. So that's the total distance. Now we need to work out the total time. Now each direction, they're flying at different times. It's going to a lot less time to go from A to B than it will from B to C. So what we're going to do is we're going to take a look at the time for A to B. Okay, so A to B. Now what we're given is the speed. Now speed, again, is distance over time. But I want time, right? Because that's what I'm looking for. I want the time it takes to go from A to B. So what we're going to do is we're going to rewrite this as T. Okay, you'd bring the T up here, and then you'd bring the S down. It's cross multiplication. So we get T equals D over s. Now again, I don't know d, but you know what? I'm just calling it d. But I do know s. S is the speed of going from A to B, and that's 150. So it's going to be d over 150. And actually, that's as good as it gets. All right, now when we want to go from B back to A, it's going to be the same thing. We know the speed. Okay, I'm just writing down the formula we're using. But I'm going to solve for t. All right, so then that's going to be d over s, but it has a different speed, right? It's still traveling the same distance. They're both d, but this one's traveling at a slower speed, so that's 128. Now this is time. Okay, and then the time to go from B to A, and then this is also a time. Okay, these are actually the two times we need. So back up here, when I said I needed the total distance, which I have, I also need the total time. Oops. Let's call that time. I should actually just call that t, and then total. That's going to equal the time it takes from A to B, and then the time it takes from B back to C. Okay, so this is the two pieces of information that I need. Okay, so let's go down. Now remember, this is the formula that we're using. So the total distance we now know as 2d, and the time, well, that's d over 150 plus d over 128. All right, so that's what I'm trying to find. Now, it will take a little bit of work. We do have fractions on the bottom, so we're going to have to do common denominators here. So the way that we would do common denominators is, here, let's actually go over here. What you're going to do is you're going to take d over 150 and multiply top and bottom by 128. Well, why 128? Because this denominator has a 128. So we're going to get 128d over, and then multiply these two, and we get 19,200. Okay, and if we do it again with the second one, we have d over 128. We're going to multiply by 150 over 150, again because this one has the 150, and that's going to give us 150d for 19,200. Okay, so now what we're going to do is these two fractions right here are actually these two. Okay, so it's going to get a little messy, but it will simplify pretty quickly. We're going to have 128d over 19,200 plus 150d over 19,200. And algebra says, or arithmetic says, once you have the same denominator, you can then add the numerators. So we're going to get 2d, still on top, divided by 278d over 19,200. Now we have a rule that if you're dividing by a fraction, you can also multiply by the reciprocal. So you would flip the bottom denominator and you would now multiply. So it's 19,200 over 278. Alright, so, and then the d. The d's cancel, which is good. So these d's cancel. And we just have to now multiply 2 and 19,200, which is 38,400. Divide that by 278, and we get 138.129 miles per hour.